Welcome back to Infinity Beyond. In our last segment, we listened to the soft, ancient glow of the cosmic microwave background, the coldest and oldest light in existence. That signal told the story of the beginning. But tonight, we shift our gaze to the end. Every story has a final chapter, and the universe, magnificent, ever-expanding, filled with stars and galaxies, has an ending too. Not in fire, not in collapse, but in cold, unyielding silence. This is the concept of the heat-death of the universe. And despite its name, it's not about heat at all. It's about entropy, disorder, reaching its ultimate conclusion. Let's unpack what this really means. In physics, entropy is a measure of randomness or disorder. It's the tendency of systems to move from order to chaos, from energy to equilibrium. Over time, energy spreads out. Differences equalize and useful energy becomes unavailable for work. The second law of thermodynamics tells us that entropy always increases in a closed system. And the universe? It's the ultimate closed system. Right now, we live in a golden age. Stars shine, galaxies collide, black holes devour, planets orbit. There's structure, complexity, beauty, but it won't last forever. As the universe continues expanding, galaxies will drift farther apart. Star formation will slow as raw material, hydrogen, becomes scarce. Existing stars will burn out. Supernovae will cease. Black holes will dominate. Let's fast forward in cosmic time. In 1014 to 1015 years, star formation stops entirely. White dwarfs cool and fade into black dwarfs, cold remnants no longer radiating heat. The universe enters the degenerate era. Then in 1039 years, even protons may begin to decay, dissolving the last remaining matter into subatomic particles. Black holes persist, but they too evaporate via Hawking radiation, slowly leaking mass, yin and energy over unimaginable eons. Eventually, all that's left is a thin haze of photons and fundamental particles, cold, motionless, silent. Entropy at maximum. No gradients, no energy differences, no life, no light. This is the heat death, also called the Big Freeze. The universe will still exist, but it will be cold, empty, quiet. And yet, there's a haunting beauty in this ending. It's not apocalyptic. It's not dramatic. It's a gentle fading, a cosmic exhale after a trillion lifetimes. A slow dimming of the lights, a return to stillness. The philosopher in us might ask, does this make everything meaningless? If all of existence ends in silence, what's the point? But perhaps the answer lies in how we live before that silence. The stars we witness, the questions we ask, the meaning we give. Let's go deeper. Some theories challenge this ending. The Big Rip hypothesis suggests that dark energy might increase over time, eventually tearing galaxies, stars, and atoms apart. Another idea is the Big Crunch, where expansion reverses and the universe collapses back into a singularity. But current observations suggest that expansion is accelerating, driven by dark energy. This makes the heat death the most widely accepted scenario. Still, science remains open. We may discover new physics. We may find that dark energy evolves. We may even learn to manipulate entropy itself. What about intelligence? Could advanced civilizations survive such an ending? Some thinkers propose information harvesting strategies, civilizations storing energy in black holes, slowing time perception, or using quantum computing to extend consciousness far into the future. Others imagine building artificial universes or escaping into simulated realities insulated from entropy. Fascinating ideas, but speculative. The universe may simply outlast everything. There's a strange comfort in that. Because knowing the ending doesn't ruin the story, it enhances it. Just like a beautiful piece of music, the universe has a crescendo, a finale. And we are here, listening, alive, at the perfect time. We are not too early when the cosmos was chaos, not too late when everything will be quiet. We are here when stars shine and galaxies dance, when life can ask questions, when you can wonder about the end. So take a breath. Look up at the night sky. Every photon reaching your eyes is part of that fading energy, those final sparks in a darkening universe. Yet, in this moment, you exist. Conscious, curious, cold is coming, but not yet. There is still time, still warmth, still light. In the next segment, we'll explore how black holes, the most extreme objects in the universe, may linger as the last monuments to time, how they shape the endgame, and what happens when even they fade. Until then, remember, the universe may end in cold silence, but right now it sings.